Welcome everybody, I'm Nikos Mikhail, here is Triadapoulos Tsakmakis, and today our topic is redesigning cloud data lake for the future. So some introductions, I'm the guy on the left, I'm the data platform team lead at Kaizen Gaming. Triadapoulos.
And I'm Triadapoulos Tsakmakis, I'm an SRE DevOps engineer at Kaizen Gaming working with a data team.
So our agenda for today, first of all, some introduction about Kaizen Gaming, about data, and particularly about the data platform and the challenges that we face. And a lot of these challenges stem from our architecture. So we're going to see our old architecture, what problems this caused. We'll have some light theory here about cloud. Hopefully you don't get bored. And how we propose the new architecture to solve these challenges. And the last part is about the migration process. So new architecture means always a migration. So how we approach this project to distinct phases, how we migrate our infrastructure, our code, and our data, and some conclusions and lessons learned. So first things first, Kaizen Gaming, we're a game tech company. We operate in online gaming and sports betting. And currently we are over 18 markets globally under Betano brand. And the goal is to be in 26 markets over 2026. We have 13 million active users, and in our site we serve over 1.5 million gaming events per year. So this means a lot of business data generated each day. And this data end up in our data lake. So currently in our data lake we have over 2 petabytes of information. We have a lakehouse architecture, so the storage part is in Azure Databricks, in Microsoft Azure, and for the compute we use mostly Databricks. And some other metrics for our velocity. Daily we have over 400 million transactions across all markets, and at peak service hour we have over 400,000 transactions per minute. Also what's impressive here is the scale, that the rate of the growth. So in just 10 years, we went from 27 million transactions per year to 121 billion. You can see this trend that's almost exponential, and we expect this trend to continue in the future. So scalability issues are really important for us. So a lot of people also work in the data department. So currently, the top-level management views being data-driven as a core strategic capability. It's labeled under data DNA. And we have over 150 people working on data, BI, and AI teams in various roles. And those people serve over 85 departments internally. And the footprint inside the company is over 1,000 end users internally. And to tackle this complexity, we use some ideas from data mesh. So we have teams focused on specific domains, business domains. And we have these teams to deliver value directly to stakeholders. And the platform team supports this team by providing tools and capabilities. So what are the challenges for the data platform? Okay, you shouldn't see this. First of all, our architecture spans a lot of years. Some decisions that were made in the past were done with a different intention. So it was most important for us to deliver value to stakeholders quickly versus optimizing. And this meant that we accumulated a lot of technical debt. So some decisions that we made in the past was good enough up until now, but do not fit our scale or our ambition anymore. So what are these decisions? So we have some shared resources, like in our old architecture, storage is a shared resource. So this means that different teams, different projects, different environments even, compete for the same quotas and the same limitations. So this is problematic. Also, you can't have true environment isolation and having your dev, your staging, your production. It's difficult to have software development lifecycle principles. Also, it's difficult to attribute costs between projects and to understand where your costs are coming. And governance, of course, is trickier when you have shared resources. Another pain point for us was everything was set up manually through Azure portal. So this meant change management was difficult, and also it was error prone. So we had an opportunity to combat this technical debt. An initiative was launched across tech department to migrate to a single cloud account, and this was our opportunity for us to focus on the problems that really matter for us. So first of all, scalability. We want a data platform that can scale for an increasing volume of data and an increasing people working on the same data without any performance degradation. Also, security is important for us to have a strong governance model, to be compliant with regulations, etc. And the last parts are all, of course, about money. So we want to be able to attribute costs to specific teams, to specific projects, and use this information to be efficient, to eliminate waste in our process, in our pipelines, and our eventual goal is to reduce operational expenses in cloud. Under the hood, we had some other goals as well. We want to establish some domain boundaries. So each team should be able to eventually work independently inside their domain, so not having coupling between teams. And our ultimate goal in the future is data democratization. So this is the notion that business can have access to quality, timely information without any barriers. So Triadaphilos will guide us through the cloud part.
Thank you, Nikos. So let's have a look at our infrastructure about Databricks. But first of all, why Databricks? No.
Can you hear us?
Can you hear us? It's okay now? No? No, it's not. Yes, it is. The words are painted there. So, why Databricks? Well, being in a Databricks conference, I will not elaborate on that one. But where can we find Databricks? Where is Databricks hosted? Databricks is provided as a service on all big three cloud providers, AWS, Azure, GCP. And selecting one or the other does not really affect the actual implementation. But where does one start if he wants to build infrastructure in the cloud? And framework is always helpful in such cases. And in this case, Cloud Adoption Framework provides documentation and tooling to help you build a reference cloud architecture. Our provider of choice was Azure, and their implementation of this framework is based on Terraform, the de facto infrastructure as code tool. The key element in all cases of this framework deployment are landing zones, which are containers for cloud resources. Of interest in our case are the data landing zones, which host the workspaces and the data themselves, as well as the data management landing zones, which host the Unity Catalog and Metastore resources. In Azure Cloud, this landing zone is implemented as a subscription. But what exactly is a subscription? Fear not, because some definitions are coming. So these are some terminology and hierarchy on the cloud of Azure. First of all, we have a tenant, which is an identity and access management service. Then we have subscriptions, which are used to isolate quotas and billing of the resources deployed. Then we have resource groups, which are groups of logically related cloud assets. And then we have the resources themselves, like workspaces, storages, virtual machines, networks, and so on. But since we are talking about a cloud redesign, we need to know from where we started. So as Nikos mentioned earlier, we had a single Azure tenant with a common shared subscription for all our resources, and this has caused quota overlapping issues in multiple occasions. Also, we had a single storage with a common configuration for all our data, regardless of their type and peculiarities. And as also Nikos mentioned, adding insult to injury, most of our resources were deployed manually through the Azure portal itself. So for all these reasons, FinOps like cost transparency and cost attribution became very difficult, as well as scaling. So taking a step ahead, we would implement a new architecture, but we had to decide about many things. We would implement the cloud adoption framework mentioned earlier. So we would create various landing zones that were used to separate lines of business, departments, and environments. This meant that we would create multiple workspaces, but we needed some capacity planning so that, because there is a soft limit set by Databricks on the number of workspaces in each account, which is about 50, and we need to be careful not to cross that limit. Also, we need to take care about the sizing of the networks in each case, because too small networks meant that we would not be able to spin up enough cluster nodes for the clusters, for the Databricks workspaces, but too large networks meant that we would waste a lot of IP addresses, something that is really important in the very big organizations or very big setups. Also, we should take care of the synergy of resources and review the way that we would break up the resources, the workspaces, the vaults, the storages to the various teams and environments. And also, having witnessed the expanding costs of having a single storage, we would create multiple storages with different configurations for redundancy and replication, depending on the data they would host in each case. And we needed to take into consideration all these, not only for the current situation, but also keeping in mind the constant and huge growth of Kaizen, as Nikos mentioned earlier, so that we should remain future-proof. So for the new architecture, having security in mind, we totally separated the production environments, for the production workloads from all other workloads, and we created one Azure tenant specifically for production, and another Azure tenant for all other environments, like development, staging, and so on. The teams would have workspaces in multiple landing zones, and in each tenant, we would have a data management landing zone to host Unity catalog resources, and also multiple landing zones that are used to separate environments and departments from one another. And in each one, we would have resource groups for the teams themselves, and for the teams belonging to each environment and department. And where needed, we would have a common resource group for the resources that are shared among all the teams of this specific environment and department. In each of these resource groups, the teams would have their Databricks workspace, their key vault to host their secrets, and one or more storages to host their data, and with proper configuration depending on the data in each case. So, as mentioned earlier, we replicated this tenant setup twice, one for production and one for non-production workloads, and the teams would have workspaces in multiple landing zones that would mean different environments in each case. There was a development environment where teams could develop their jobs by directly connecting to the workspaces, and then they would commit their code to a Git repository. Then after that, a staging environment existed where that is used for end-to-end testing, and the deployment there happens through pipelines, CI/CD pipelines, by using Databricks Asset Bundles. In this stage, production data can be consumed if needed for the testing, and this is available by utilizing delta share. It's somewhere down there below the titles. And the delta shares being read-only would help us ensure that there would be no data disasters during the testing phases. And also, for the final stage, we had a production environment where, through a merge request and approval procedure, deployment happens to the production environment. So, what have we achieved with this new setup? we have achieved better scalability due to setting boundaries and limits and isolating resources to have different quotas and separate quotas using different landing zones, which are subscriptions that isolate resources as we saw. We have improved FinOps because of we have cost transparency, cost attribution. Each team, each environment is on a different landing zone, so these things are separated and are easier to find where each cost belongs. And we have cost optimization because of resource flexibility. We have multiple storages instead of one, and we can configure it. We can configure the storages as needed for each data type. And then, of course, we have better governance because multiple workspaces allow us to configure better and access control. Also, isolation between, for sensitive data, having a different production than other environments. And of course, instead of deploying manually, we use Terraform and infrastructure as code, so we have resource standardization and consistency, and also change management. And all this leading us a little closer to our goal of achieving data democratization. So now Nikos will talk about the process of migration. Thank you.
Hello again. Can you hear me? Yes. So, migration, a famous quote, nothing can be certain except death and taxes. I will add to this data migrations as well. So, a quick poll here. Please raise your hand if you've ever been a part of a migration project. Okay, more than once for me. So, you know the pains. So, our approach here is to split this project to 3 distinct phases, before, during, and after. And each phase has distinct goals. So before migration, we needed to design our security model, which is tied as well to our data governance part. We need to understand our limitations because we have developed a lot of services that expect to work in a single environment setup. And also, before starting implementing, it's the best time to define conventions, standardize namings, etc. Once you start implementing, this is very hard to do. For the actual migrations, we need to decide about a migration pattern. So we saw earlier that we have a lot of stakeholders, and those stakeholders expect their KPIs, their reports, etc. It's not an option to say, okay, now we'll freeze everything, and 1 month later, everything is migrated, and you will have your reports again. So we needed to find an incremental approach. And also, we need to develop our own tooling to help us do this migration. And the last part is, of course, creating the infrastructure that we saw earlier, deploying our applications, and migrating our data. After migrations, we want to check our performance. So we don't want any performance degradation going to this new setup. And we want to start using our cost insights to reduce operational expenses. So this is about cost optimization here. So about security, first thing first, we need to understand what are the main administrative responsibilities. Based on Databricks best practices, we separate this to 3 distinct administrative roles: account administrator, who create account-level resources like workspaces and metastores; metastore administrators that create securables like schemas and catalogs and delegate access; and workspace administrators that have access in workspace and can toggle on, toggle off features, create clusters, etc. So having these roles in mind, we tie to specific groups. We used this notion called group-based access control, or GBAC. And for our production environments, we exclusively used service principal. This is basically service accounts in Azure IAM. So all data access, all jobs, all infrastructure as a code pipelines run using the service principles. The next part was creating actual infrastructure. So what we did here was we used what is called Terraform modules. So modules are basically components in Terraform that have some input, have some output, and do some magic in the middle. So you need to understand only their interface. You don't need to know what happens inside. This is a nice case of abstraction. And also it helps to tackle the complexity of the kind of things, especially when you're dealing with change. So for example, we have a module that creates catalogs. So let's say you want to add a specific tag in all catalogs. you only need to go in the module that creates the catalogs and do one atomic change there, and everything is propagated. And also, we had some discussions about who should does what. On the top part, we have the responsibility of the infrastructure team. We have a separate team that create usually our cloud resources. So they created the subscription, the resource group, everything that's top level in the cloud. In the Databricks account level, we contribute both. And at the bottom part, inside the workspace, to create cluster policies, etc., we contributed as a data platform team. But our end goal is to educate our users to do this kind of stuff themselves. So this is kind of self-serve infrastructure. So about the migration, we used a lot of Databricks Asset Bundles. A quick poll again. How many of you do you use Asset Bundles in your flows? Okay, some hands here. So basically, this is a feature of Databricks CLI that's a wrapper in Terraform. So you can define everything in some files. So for example, you see here an example file that have different configuration for each environment. So all our jobs refer to these files, and you can define centrally some configurations. So for example, I have highlighted here, the Spark version means this is the Databricks runtime. The policy is the policy for all our jobs in this environment, and the service principal name. So this is defined centrally. So for example, migrating as well to a new Databricks runtime, you change simply this line here. So this is very useful for us to dealing with this complexity of multiple environments, and it streamlined a lot our CI/CD process. We also used a lot of, in the old architecture, we used Databricks file system, which is tied to each workspace. We migrated volumes. So this is across workspaces and has access control. It helped us a lot for storing our packages, our jars, our wheels, our configuration files, etc. So the most important part is, of course, data. So we had some limitations. We had a lot of tables. So this is not a typo. We actually have over 20,000 tables in views. So this is not manageable by a single team. We can't have a single team migrate all these pipelines and schemas. What we wanted to do is to help different teams to migrate at their own pace. So, and during this migration, the most important part is to have our commitments to stakeholders. So this should not disrupt our daily operations. And also, in the old architecture, we exclusively use external tables. Now we want to migrate to managed because most of new Databricks features are coming to managed. So eventually, if we want to opt in, we want to be on managed tables. So our approach here, our solution, is end users to don't understand, to be invisible for them, the migration. So what we did, we will see an example for this. Our tables were in both metastores in all the new architecture, but the data actually reside in one. And we hide this complexity using delta sharing. Our goal here is to keep downstream dependencies for our end users stable, so they don't need to change their queries and their notebooks, etc. We tested this solution for latency, for egress, etc. Because we migrate to the same cloud region, this is not a factor for us. But if you migrate to a different region, this is something you need to take into account. And this is, of course, led us to adopt a divide and conquer approach. So all teams should help in this project. So I have an example here. So on the left side, we have two tables. On the bottom, we have a table named catalog.table, and we want to migrate this. And on top, in the old setup, we have a dependency. So we have table underscore dep. In the new tenant, we automate this. We have a delta share. So this is offered for read-only through the share as share.table. But we create automatically a view that goes to this share and creates this table, catalog.table, as a selection, as a view from the delta share. So this means that our data are available for read in both architectures. So let's say you want to migrate the bottom table. We have this tooling that hides all this complexity. So we use the share to do one deep clone. So we create this table _temp. You can actually pause here and do some testing, test your applications, etc. And if you are OK and you want to continue your migration, you continue. And you do one last deep clone to sync your data. You drop the view and you rename the temp table to the actual name. So what we achieved up until now, we migrated the data physically from the old setup to the new. What we need to do now is to change our dependencies. So we use the same tooling to go back to the old tenant. We use the symmetric delta share here. And we create this view. A catalog.table now in the old tenant is a view that selects from delta share. And the old table is marked for deletion, so it's renamed to table.archive. And you can eliminate it when you feel comfortable with this. So what's important during this process is that dependency did not change. So in the old setup, I was always expecting a catalog.table, and this was always the case. So my downstream user did not change his query. And of course, we use our tooling to do this at scale. So we migrate whole schemas, etc. So our progress. Currently, we have created infrastructure for over 25 teams. So each team has multiple environments. And we have done a lot of workshops. So we do pairing sessions. We need to educate our end users how to use the setup, because this is the first time for them. And we have created the migration tooling. About the data migration part, we are currently in the middle of this migration, so it's a really big project. And after the migration, we want to focus on cost optimization. So we need to reduce our operational expenses. We want also to address the catalog. So we have a catalog with data from different domains, and we want to split it to domain catalogs. So a domain can be a specific product or customer, etc. And our ultimate goal is then users to use these modules and this stuff to self-serve the infrastructure. So I want to create a new cluster policy. I just change this repo here. So some lessons learned, some problems that we faced. It's difficult to do governance on a distributed environment. So it's important to have spend some time to understand all the complexities of this before starting implementing. Also, we had a lot of team coupling, so this is not ideal. So you need to be aware of this coupling between teams. So I expect my workflow to end, so another team should start their workflows. Something that was challenging for us is that we had different maturity between teams. So some of the teams were completely new to Databricks, so we needed to onboard them. We invested a lot of time on doing pairing sessions, to write documentation, to do video, and this kind of stuff. And also, when you need to mobilize a lot of people, it's difficult. So even though we say this is migration is each team can do it at their own pace, you need some kind of coordination. So it's nice to have this commitment. And also, some problems. For example, we had some implicit dependencies. So we migrated a table, and someone was reading this table, which was append only, as using structure streaming. So we messed up their checkpoints. So we started to explicitly check for these kind of things. So that's it for us. At the left side, you see a QR code. You can go there and see some presentation slides and the text for this whole presentation. This is the development team. I want a quick shout out to them. So thank you for your time. This is basically for us. Okay.